Okay, so for the next part, okay, on how can we reverse the order of integration, okay, for you to be able to answer the question or to solve the integrals. Okay, so where do we apply this what should I say this kind of method? Okay, so when we have an impossible looking iterated integral, okay, in certain condition, okay, even though we give you the limit, even though we give you the situation, okay, completely, means that we give you the limit, we give you the function, okay, that would like to solve it, okay, but when you take a look on the question or on the given integral, it's impossible, okay, impossible for you to integrate it, okay, using that given order of integration. Okay, so in that case, okay, we must reverse the order of the integration, okay, for you to be able to solve that question. Okay, and then okay, you must remember uh, you must remember this part, okay, for this part. Okay, so for non-rectangular region, okay, you cannot just simply swap the order of integration we like what we discussed in the previous videos. Okay, so in order for you to be able to, okay, reverse the order of integration is for you to sketch first. Okay, sketch first, identify the region, okay, identify the sketch region, okay, or the shaded region, okay, and then from there you're going to apply, okay, for the new order of integration. Okay, so let me show you. Okay, let me show you for the first one, for A. Okay, so if we take a look on this one, okay, so for this given integral, okay, so if you take a look on this one, okay, so we must, okay, we must integrate respect to y first. Okay, so if we take a look on this one, sorry, sin y over y, okay, any kind of method that you have learned, okay, in the integration topic, okay, you cannot use it to solve for this one. Okay, so that is a hint, okay, that you need, okay, that you need to change the order or to reverse the order of integration. Okay, so it means that you're gonna integrate respect to x first instead of y. Okay, so let's sketch the region. Okay, so in order for you to be able to integrate correctly, okay, you must identify the region. Okay, so to identify the region, need to follow the original order. Okay, so let's sketch it. Okay, so we have like this. Okay, so we're gonna have y equal to x, so we have line over here. Okay, and then since, okay, so since this one is dy dx, right? Okay, so at y equal to x over here, so y equal to x coming from this one. Okay, so this one we have y equal to x, and then another line is y equal to pi, so we can assume that in this region pi over here, so this has y, this one is x. Okay, and then okay, so the intersection of this point, obviously that you're gonna get pi over here. Okay, so now, okay, you must be able to identify whether that region is in this part or in this part. Okay, so we must take a look on this one. Okay, so since this one use the order of dy dx, okay, so means that it's gonna use vertical strip for this one. Okay, so vertical strip that we're gonna apply over here, okay, means that in this direction. Okay, so this one is correct, okay, between 0 and pi for the x. Okay, but for this one, okay, so for this limit, okay, the lower limit is y equal to x, means that the vertical strip should meet this line first, so that's why it became the lower limit, and then if move upward, it's gonna meet this line, which is y equal to pi. So it means that, okay, the region is in this one. Okay, so we know that the region is in this side instead of this rectangle, sorry, this triangle. Okay, so this one, okay, this one you identify based on the original order. Okay, so now we would like to find the new limit for the new order. Okay, so instead of we use dy dx, now we would like to change to dx dy. Okay, so if we would like to change, okay, to dx dy, Okay, we must remember that we're gonna use horizontal strip. Okay, so if we gonna use horizontal strip, okay, we must know that the limit for y should be a constant. Okay, so means that the strip should coming in this way. Okay, so we know that, okay, from here, from this region, that y is between 0 up to pi. So this is the limit for y. Okay, so now in order for you to get the limit, okay, the limit for x, okay, by using this trick, the green one. Okay, so from here, okay, when we meet or we go through this shaded region, okay, so it's gonna meet this line. So we know that this line is x equal to 0, right? Okay, so the lower limit for x, okay, should be 0. And then we move up to here, the end, okay, the end for the curve that actually bounded for that shaded region. Okay, so we know that this line is y equal to x, right? Okay, so we take x as a subject. So means that the limit up to y over here. Okay, so now if we write it into this form, okay, so you're going to get like this. Okay, so we have sine y over y. So now the new order is dx dy. So the limit of x is 0 up to y, and the limit for y should be 0 up to pi. Okay, so if we change the order of the integration now, so now it's possible for you to integrate. Okay, because, okay, so this one is in terms of y, right? But we must integrate respect to x. Okay, so if you integrate, so you're going to get 0 up to pi. So we have x sine y over y, 0 y dy. Okay, so now it's possible, right? Okay, so if you substitute the limit, okay, so you're going to get like this, right? You're going to get 0 up to pi. You're going to get sine y dy. Okay, so you're going to continue. Okay, so you will get negative cos y. So 0 up to pi over here. So you're going to get negative cos pi, okay, plus cos 0. Okay, so if you cos pi is equal to negative 1, right? So negative 1 plus 1 over here. So that's why you're going to get the final answer is 2 over here. Okay, so whenever the question asks you to answer or to evaluate the integral, okay, but you need to reverse the order of integration, first thing first, okay, sketch the region. Sketch the region, identify the shaded part, okay, and then get the new limit. Okay, so that is the first one. Okay, so let me show you for the second question. Okay, so if you take a look on the second question, okay, similar. Okay, so similar for this one. It's impossible for you to integrate respect to x first. Okay, so you do not have any option. You must change the order of the integration. So now our aim is to change to this part. Okay, so if we sketch the region, okay, if we sketch the region based on the limit, okay, using the same concept, okay, so you're going to get x, going to get y over here. Okay, so we have x equal to y over 2, and then we also have x equal to 1. We have x equal to 1 over here. Okay, and over here is going to be 2 over here. So this line is x equal to y over 2. Okay, so based on this limit, okay, based on this limit, okay, you should know that the shaded region is in this part. Okay, so that is the shaded region based on the original question. Okay, so now the new one is in this order, dy dx. Okay, so when we would like to get in this order, dy dx, okay, so you must remember that we're going to use vertical strip. Okay, so vertical strip that we would like to use, okay, should coming from this direction. Okay, where the limit x should be from this part to this part. Okay, so over here should be 1, right? Should be 1 because x equal to 1 for this part. X equal to 1, right? Okay, so means that the limit for x is between 0 up to 1. Constant limit, right? Constant limit. Okay, so the limit for y should be in this way. So from this one, you're going to meet this line. Okay, so this line is y equal to 0. Okay, and then we're gonna move to this part. Okay, so if we take a look on this part, we have x equal to y over 2, right? Okay, so since the limit is y, the limit for y that we are looking for, so we make it y as a subject. So we're gonna get from this one y equal to 2x. So means that the limit for y is 2x over here. Okay, so the new, okay, so the new limit, okay, the new limit for this question should be in this way, 0 up to 1, okay, 0 up to 2x. Over here is negative x square, okay, so the new order is dy dx. Okay, so after that you're gonna integrate as usual. Okay, so we're gonna integrate respect to y first, so we're gonna get y e x square. So 0 to x, sorry, 0 to x dx over here. Okay, so if you substitute, okay, so you're going to have like this, 0 up to 1, you have 2x e x to the power of 2 dx. Okay, so if we have in this form, okay, so we're going to use substitution method. So let u equal to x squared. So we're going to have du equal to 2x dx. Or we can also write du over 2 is equal to x dx. Okay, so that you can replace this part. Okay, so if we replace it, okay, so we're gonna have 0 up to 1 eu du. I should have 1 over 2 or not? Give me a moment. 2x, right? Okay, 2x. Oh yeah, no need for this one. You can just replace for this one because we have 2x for this part, right? Okay, so we can just replace this one with du. Okay, so you're gonna get in this form. So now it's easy for you to integrate. So integrate e to the power of u should getting eu as well. Okay, 0, 1. But we must remember, okay, so this limit is in terms of x, right? So we know that u is equal to x squared. Don't forget to replace it. So e x to the power of 2, 0, 1. So you're going to get e to the power of 1 minus e to the power of 0. Or you can also simplify e to the power of 1 minus with 1. So this is the final answer for the second question. Okay, so that's how you solve it. Okay, whenever you are dealing with the integral that is impossible for you to integrate, or the question specifically asks you to change or to reverse the order of the integration. Okay, so that's all for this video. Thank you.